All right, so we'll explain the drinking bird. This is a complete HVAC science piece of equipment right here. So what happens, we have water here, and I first have to put his head into the water, and this velvet material soaks up water very well. So when I first put his head in that water soaks up through that material. Now when it's sitting like this, what's happening is evaporation, especially in a dry climate like this. That water that's on his beak evaporates, which means it's changing state from a liquid form to a vapor form. What happens every time a substance changes state from a liquid to a vapor? Every time a substance changes state from a liquid to vapor, it evaporates every time. It's right on the board. Every time a substance changes state from a liquid to a vapor, that substance absorbs heat. Every time a substance changes state from a liquid to a vapor, it absorbs heat. Is the water evaporating off his beak? Is a substance changing state from a liquid to vapor? Is that substance absorbing heat? Yes. Yes, so the water is absorbing heat. What kind of effect is evaporation?
Cooling.
Evaporation is what kind of effect? It's a cooling effect. So if I spray water on you and you walk outside to put a fan on you, how's that going to feel? It's going to feel cooler because it's a cooling effect. The water is absorbing heat. So when we dip his beak into the water, that water is evaporating. As that water evaporates, the water is absorbing heat. What kind of effect is that? A cooling effect. Good. So it's cooling off the head, right? Because it's all wrapped in that velvet material?
Yeah.
So it's a cooling effect. So what's going to happen to the temperature of the bird's head here?
Isn't that cool though?
It's going to drop. The temperature is going to drop. As we absorb heat away from it, the temperature is going to drop. So now, as the temperature of his head is dropping, that's in a sealed bulb. So as the temperature of that starts to drop, what happens to the pressure inside of that tube right there?
It drops.
The pressure drops, right? The pressure drops. So then we're going to end up with a pressure difference between the top and the bottom. So if there's more pressure in the bottom than there is in the top, is there going to have any kind of a travel or any kind of change? Yes. So the higher pressure is going to start pushing that liquid towards the lower pressure in the head. As that liquid starts traveling towards that lower pressure, the weight of that liquid is going to cause it to be above this balance point, and it's going to cause the head to dip back down into the water. When the head dips back down into the water, it allows for the vapor and the liquid to equalize in that tube, and it all equalizes back out, and the liquid will end up draining back to the bottom. The head, it pops back up until evaporation happens again. And as it evaporates, we have a temperature pressure. As that temperature up here starts to drop, that fluid is being pulled up through here. Once enough fluid gets up in here, it dips its head back into the water, picks up more moisture to allow more evaporation. The drinking bird works completely off of HVAC principles.
Cool.
It is cool, isn't it? And actually you can see that the fluid's starting to come back up again. If I can speed up evaporation. It'll happen faster. So, in the summertime, does it feel cooler if you have a fan on you or without a fan on you?
With the fan.
With the fan. Why?
Evaporation. Your sweat's evaporating.
Two things. One is just your body's putting out heat, radiant heat and conduction heat. And if I'm moving fresher air across me constantly, that heat that I'm heating up the air around me with is constantly exchanged. So I'll constantly have cooler air coming around me. The second thing is evaporation. Your body is mainly moisture, and it puts all the moisture on your skin. And even though you're not sweating, there's still moisture in your skin. As I put that fan across it, it speeds up evaporation. For every 1 pound of water that evaporates off your body, it absorbs 970 BTUs of heat energy, which cools your body. When your body starts to get very, very hot, it starts to dump extra water on the skin because it needs to cool off. Your body knows about evaporation before you do. It automatically dumps extra moisture out there to help keep you cool. That's why when you go to a place like Florida and the air is full of moisture, is there going to be much evaporation? No, because the air is already full of moisture. It's not going to evaporate very quickly. Make sense? Okay, but that's how this works. As that evaporation happens, it'll happen faster.